Hey everyone, my name's Yi. I'm one of the co-founders of Axiom, and today I'm going to talk to you about how you can build custom slashing conditions for your AVS using Axiom. So first of all, what is Axiom? Axiom provides smart contracts on Ethereum, in particular your AVS slashing smart contract, with ZK verified access to any piece of data from the entire history of Ethereum and ZK verified compute over that data. So that includes things like transactions and receipts that are traditionally not accessible from within the EVM. And we've developed a JavaScript front end for you to actually specify what historic data you want to access, what ZK verified compute you want to do over that data, and we generate ZK proofs of the validity of historic on-chain data, the validity of computation over that data, verify them on-chain, and send the results as a callback to your AVS slashing contract. So you can check it out at repl.axiom.xyz. And crucially, for something as high stakes as slashing, every result that we return is cryptographically equivalent in security to something you're reading directly from Ethereum within the EVM. Okay, so what does that have to do with an AVS? Well, a key part of restaking is the ability to actually slash the restaking nodes that are supporting your AVS. And so crucially, the slashing must be done with an on-chain smart contract. And therefore, the conditions you can express are limited to those that you can actually verify within the EVM. So what Axiom can provide for AVSs is the ability to express more custom slashing conditions that aren't traditionally available using standard EVM techniques. So as I mentioned earlier, you can access transactions and receipts, so events that your AVS operators did or did not trigger. You can access the full history, meaning you can see whether a user balance changed from the last hour until now. And also, you can compose your AVS slashing conditions with data from other applications on Ethereum that maybe did not intend for your AVS to be involved. So maybe that application is not storing a relevant fact for your slashing condition in state, and instead emitted it as an event. With Axiom, you can access the data from that event and put it into your slashing condition, just giving you a more expressive way to constrain the behavior of your AVSs. So just a couple examples of types of conditions you can impose using Axiom. We can allow you to constrain transaction ordering within a block in a totally custom way. So you can access details about the first transaction of the block, the last transaction, or any transaction in between. And we also allow you to mix and match transaction indices and block numbers. Similarly, if you're trying to constrain a keeper network, you can check that the trigger that's supposed to cause keepers to perform some on-chain action actually held at some block in the past. And therefore, you can penalize keepers for non-performance. So I'm going to show a quick demo after this of how you can write a ZK circuit to prove that there is an omitted keeper trigger. So the setup is that we have an AVS that's using EigenLayer to provide economic trust behind keeper actions. So keepers are supposed to do certain things on chain when some trigger conditions are met, and restaking is supposed to enforce that this actually happens. As an example, imagine you're on Gurley and you are terrified of having your Gurley ETH in the layer 0 Gurley ETH bridge. So what you want to do is that if the assets in that bridge drop by at least 50%, you want the keeper to just withdraw you from that bridge. Okay? So what happens if the keeper doesn't do it? Well, you can't really penalize them unless you can prove that the number of assets actually dropped by half. And so that's where Axiom comes in. And in the next slide, I hope the video works. Okay, so you can't hear me talking, but here we have a JavaScript interface to Axiom, which allows you to specify that you're fetching the account balance you're fetching the account balance at a start block and end block, checking that the start and end blocks are within 1 hour of each other, and then checking that the balance dropped by at least 50% in between the two blocks. You then specify that you want to send to a callback to your AVS contract the start block, start balance, end block, end balance, and whether or not there is a big drop. So we allow you to generate a zero-knowledge proof of whether this happened. And let's see, my talk track is no longer synced with the demo, but you can see that there's a client-side ZK proof being generated over there. And then we allow you to send a query on-chain to authenticate the two balances that are being referenced here. Once that's authenticated, we will send a callback containing these ZK verified values to your contract, and you can decide whether to slash or not. All right, so that's it. You can check out Axiom on our Gurley testnet, so at repl.axiom.xyz. We have our V2 docs at the link over there, and you can go to our Telegram group to learn more with the QR code. Thanks, everyone.